Good day, wizards. Welcome back to your lesson for trigonometry. Remember, we said that trigonometry is a very broad branch for mathematics. There are so many things that you can learn in trigonometry. What are some of the things that we have learned thus far? We have learned some trigonomic ratios such as sine, cos and tan. We also learned their reciprocal ratios, sec, cosec and cot. We also learnt about double angles. We learnt about double angles, we learnt about compound angles, and we also learnt about some special angles. Which are those special angles? Your special angles or your special triangles refer to your 30 degrees, 60 degrees, 45 degrees. We can also include 0 degrees and 90 degrees for your broadened aspect of special angles. What else did we learn from trigonometry? We learned some proofs. So in the previous video, we learned how to do a proof. Go ahead and watch those videos so that you can understand how we are progressing to the next aspect. Today, we are going to be speaking about double angle identities. Double angle identities means just that. When we learnt about double in the previous grades, we learned that double means the same thing as multiply by 2. Therefore, in your trigonometry ratios, double angles mean the same thing. They mean doubling a ratio. For example, sine 2 theta or sine 2 of an angle. What does that mean? Sine 2, so some angle multiplied by 2. Sine 2 theta is equal to 2 sine theta cos theta. That's pretty simple. If I gave you an example and I said sine 2 theta, you can simply add that by saying sine 2 theta is equal to 2 sine theta cos theta. We can also look at cos 2 theta. So cos 2 theta is equal to cos squared theta minus sine squared theta. What does that equal to at the end? We can say that cos 2 theta is equal to 1 minus 2 sine squared theta. And then we have the last ratio, tan. If I were to say tan 2 theta is equal to 2 tan theta divided by 1 minus tan squared theta. Let's jump into a description or a visual of these double angles and see how we derive half angles.
So wizards, just to have a visual of what we were trying to say, you can see that I have my double angle formulas and I have my half angle formulas. Like we went through the double angle formulas together, let's go through some of the half angle formulas, such as sine squared theta. Sine squared theta is equal to 1 minus cos 2 theta, all divided by 2. Sine of theta divided by 2 is equal to plus or minus the square root of 1 minus cos theta divided by 2. Now wizards, this can get pretty complicated when we work with 2's and square roots. So pay careful attention and remember to try to learn them off by heart as much as you can. The next one is sine squared theta, which is equal to 1 plus cos 2 theta all over 2. The second last one is cos theta over 2, which is equal to plus or minus the square root of 1 plus cos theta divided by 2. The last one is tan theta divided by 2 is equal to plus or minus the square root of 1 minus cos theta all over 1 plus cos theta. So what we have here are double angle formulas and half angle formulas. Now you would need to derive some of them, as I said earlier, and you would have to do examples that involve these formulas. Let's take a look at the example. It says if alpha is an acute angle and sine alpha is equal to 0,6, determine the value of sine 2 alpha without the use of a calculator. What is my first step? My first step is always draw a sketch. In order for us to draw the sketch, we need to convert. If I convert 0,6 to a fraction, I should end up with 6 over 10. But we are working with sign. So what does sign represent? Sign represents the opposite over the hypotenuse. What else does it represent? Y over R. So sign represents Y over R. Let's try to draw that on a Cartesian plane. Let's say that the triangle exists somewhere on the positive side. Remember that the value of Y is going to be 6. The value of R is going to be 10 from the example that we have. So what can we say then can be our next step? We've drawn our triangle. We know that this is 6 and this is 10. What do we need to calculate? We need to use theorem of Pythagoras that states x squared plus y squared is equal to r squared. So x squared is equal to 10 squared minus 6 squared. That's going to give me 100 minus 36. What am I going to be left with? I'm left with 64. And the square root of 64 is plus or minus 8. So if we are saying we are using the positive side, we are saying that this value is now 8. Once we have that, we can go ahead and use the double angle formula. Let's use the double angle formula to determine the value of sine 2a. The value of sine of 2 alpha is equal to 2 sine alpha cos alpha. If you remember, we learned that using our double angle identity. So let's say alpha exists at the base here. Remember we said according to sine of alpha we got 6 over 10. So according to cos alpha, what would we have? Cos alpha adjacent, which is 8, over hypotenuse, which is 10. So that's going to give me 2 into sine alpha, which was sine alpha, 6 over 10, and cos alpha, which gave me 8 over 10. Once I do that, I end up with an answer of 96 over 100. Can I see that that answer can be simplified? When I simplify that answer, I want to say that this is equal to 0,96. Why am I saying 0,96? I want that in a decimal form. I want that in a decimal form so that I can check my answer later on. So what will I be left with? I will be left with the following. I will say sine 2 alpha is equal to 0,96. Now, there's a very simple way for you to check your answer. You will use your calculator to check your answer. But remember, you cannot use the calculator throughout this exercise. You can only use the calculator at the end when you want to check your answer. So you'll check your answer by saying sine alpha is equal to 0,6. And if I put that, I can say that alpha is approximately, so not totally, but approximately equal to 36,87 degrees. And that is once I round off the answer. I can then say that 2 alpha, which is multiplied by 2, is approximately equal to 73,74 degrees. So if I put that into the calculator, I can say sine of 73,74 degrees is approximately 0,96. So what have I done? I have said that sine 2 alpha is equal to 0,96. When I work backwards using my calculator only to check my answer, I arrive back at 0,96. So that's just a method of helping you identify whether your answer is correct or not. Now the things that you need to understand from this example is that we use theorem of Pythagoras when working with 90-degree angles or when we are working with a Cartesian plane. We need to learn the definition SOHCAHTOA off by heart. SOHCAHTOA. And we need to apply that by saying SOHCAHTOA in terms of x, y, and r gives me SYR, C, X, R, and T, Y, X. So those are all the values SYR, CXR, and TYX. That's in terms of your x-axis, your y-axis, and your r-axis. That will help you when you work with triangles that are not necessarily opposite or adjacent and that are on a Cartesian plane. So wizards, you need to understand how to use both and how both go together. We also know that you cannot use a calculator for this example. You can only use the calculator when your answer needs to be checked. So wizards, remember that this is an example using sine. There are many more examples using cos and tan.
So wizards, we've learnt a lot. We've learnt about double angle identities, but we've also learnt about half angle identities. So that's a lot to learn. But what else did we learn from our screencasting? We learned how to apply that using a Cartesian plane. When we learned how to use the Cartesian plane, we used what we learned about from trig and all our identities. So wizards, I hope that you would go ahead onto the iWhiz website. You can find the iWhiz website as follows. Log on to the website and do as many examples as you can. Those worksheets help you progress in the knowledge that you need from one example to the next. Remember that practice makes perfect, and for you to be really good at trigonometry, you need to do as many examples as possible.
We need to learn to live with the COVID virus, you know, the new normal, at least for the next few months. And we have just what you need to make sure you never miss a single school lesson. And it's absolutely free, mahala! High quality, powerful, animated lessons for all your subjects. So don't spend a cent until you have tried iWhiz. It's everything you need. All video lessons, textbooks, workbooks, exam prep. We want you to ace 2021.